First of all, thanks everybody for coming. The topic for tonight is journey from the Java side. A little bit of background from me. So I've done most of my Selenium stuff in Java. But recently at Airware, we decided to do Node.js because everybody's moving to full stack. The dev guys are Node.js front and back. And we decided to use the functional testing in Node.js as well. So this is the agenda. So we go through some backgrounds. Some challenges along the way. Page object implementations in JavaScript. How is it different from Java? Integration with Applitools, which is the tool we choose for doing screenshot validation. Also doing backend testing using HTTP requests for REST APIs. And then after tests, we hand over to the backend and deployment team on the tools to roll out the cloud, deploying to prod. So a little bit of background. Back in June, we started looking into Node.js Selenium frameworks, keeping the Node adoption in mind because everybody's moving to Node.js these days. And we want to share code with the front-end guys and also the back-end guys and get help. So this is like the stack that you typically get on a Selenium implementation. The first is the classic one, is Java. You have a middle tier, which is JavaScript, and then you have a back-end, which is like Tomcat using Java. The next blend is Python, Python WebDriver. Still, the front end is always JavaScript, back end is Java, and then you have Water WebDriver Ruby or Capybara, and you have JavaScript. So this is what we wanted to do. So we wanted everything to be Node.js. And we have a disconnected engineering stack since everybody has different languages. Having a clear communication or having collaboration across the stack is kind of challenging. So this is in the marketplace right now. A typical front-end engineer, JavaScript, Backbone, Angular, which is up and coming, Node.js, high charts. And this is from the same company. This is the front-end engineer. This is the automation engineer. But you can see they're using Java, Python, Perl. So obviously, it's the norm in the industry or the majority. OK, so Googling Node.js and Selenium, you get a ton of stuff. This is my closest emotion or representation when going through all this. We get Nightwatch, Webdriverlo, a bunch of stuff. The intern, which I just found out at this Selenium conference that people were using. I don't know why they call it intern in the first place. You have Cabby, which is from Taxi, I guess. Selenium WebDriver, which is the official one, and then Protractor, and then many more. Challenges. JavaScript 101, it's async. What do I mean by async is if you write code and you have a non-blocking call that you're expecting operation, Node.js or JavaScript will not wait. So it will just follow through. Here I have code that iterates over this array and does stuff to it and then prints the array at the end. But as you can see from the output, this guy finished first. So this is the main challenge. Everybody from a synchronous programming like Java or Python moves to Node.js, you will hit this first hurdle where it's async. And you can see that this guy got printed first, finished, got printed second, and then later on, all this stuff gets followed through at the end. This is my first 2 weeks when working with Node. It's really challenging. And it was a really painful first 2 weeks. So to conquer the synchronous, what the JavaScript developers on the front end have at their disposal is callbacks. What does callback mean? So every operation, you pass in a function at the end, signaling that the operation is done. Then you start to do your stuff. So this is the equivalent code in Java where everything is blocking and it's synchronous. Everything falls from top to bottom. But then if you're using the callback, you get this really ugly pattern here, which brings me to my next point. It's called the pyramid of doom. So you can see the pyramid forming. It's not Indiana Jones. It's just a pyramid of doom, which really will lead you to doom because you can't manage your code anymore. And in the end, in the middle, is where you finally get your title and you can do stuff with it. Take note that this isn't encapsulated in the page object yet. It gets even messier if this is in a page object. This is a real-world example. It's taken from Marcel Ertz from the South Bay Selenium meetup. I think it was early this year, I think. So this is where you get your link element. You can see all this. You open up the link, all that. You're still in the pyramid of doom. The next pattern is promises. Here we still have the equivalent Java code, top-down, synchronous. In promises, what you do is you have a .then. And once you have a .then, you still need to pass a function. And in that function, you do your next operation. Then you return it. Then you do a .then. A little bit better than the pyramid of doom, but it's still pretty gnarly because everything's totally messed up. Are there any Node.js developers here? OK, I'll keep you guys in mind. Yes, so these are the main two mechanisms to get around synchronous. This is a promise example, again, taken from Marcel's example. You have a bunch of returns that change the promises, and then you finally work on your web element here. Kind of gnarly. I didn't really like it at first, but that was the best we could find. So back to the list. When you start working on Node.js and Selenium, you can get into the wrong path really, really quickly because there's a bunch of stuff online. I think the official bindings were just implemented recently, and because of that, they were like implementation of this before, done by developers. And you still have this. These are like the main popular ones, but you still have stragglers around. So if you take the wrong pick, it takes you down the wrong path for quite a while. Another gotcha that you will find is that Webdriverlo, it used to be called WebDriver.js before. But then the official bindings is now called WebDriver.js, which the lower s. And then now this guy is called Webdriverlo. So if you Google Webdriver.js, you will get rerouted to materials from this guy. And it even adds to the confusion of what to use, what's the official libraries. And this talk is to actually try to set this record straight, that you guys should know what you're searching for and what you should be using. Experimenting with Nightwatch. So I think I talked with Marianne earlier this year, because I think she did some Nightwatch stuff before. And Nightwatch is pretty popular. It came up first in the search results. It has like 3,000 something stars on GitHub, so why not? Let's try it out. So Nightwatch offers a chain-based API. So they give you a browser instance or an object, and you can start chaining stuff along with it. And this is typically a Nightwatch test. It implements a JSON, the Selenium JSON wire protocol, offers some form of page object support where it's just a JavaScript object with a bunch of CSS selectors where you can just do some code refactoring. But it's not ideal. It supports some kind of browser stack and sauce labs out of the box. Pretty good documentation, really pretty, which is why we kind of fell for it first. And we also experimented a little bit with Webdriverlo. You can see that most of these are all chain patterns, which doesn't really help with page object pattern or page object implementation. It does the same thing, but Webdriverlo is a little bit better. It offers some integration with Applitools, but using another child library. It's A+ promise support, but it's still chained APIs. Integration with sauce labs and browser stack is out of the box as well. So we talked about chain APIs. Let's see. Oh, before we go to that, sorry. So I talked to Kristen Broman, who is the creator of Webdriverlo. He did admit that this chain API pattern is a challenge to implement in the page object pattern, because what you have in the end is just a chain of commands. And in your page object is a shortcut method, has another subchain of commands. So you still have a chain within a chain within a chain. There's some links here you guys can follow, but there's still open issues on Webdriverlo on how to implement good page object patterns in Java or in Python. Chain-based. This is the nice part. If you don't do stuff, if you don't do complex stuff, you just want to click, 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 and return the browser, it works fine. So this is a page object in Nightwatch. You can see that it's just another subchain. And this guy verifies, sorry, click lockout is calling this subchain here. So what you end up is just a chain within a chain within a chain. Now the ugly part is when you start to iterate or work with data, you need to add stuff to an array, you need to do looping. The chain is broken. And you still have this pyramid of doom, because when the chain breaks, you still need to tag on to that execution and start the next execution inside the callback, or the innermost, where you just broke the chain. This is a method within the page object. So if you start to iterate and you start to create a data structure, you still need to break the chain, break the chain, break the chain, and you still get a pyramid of doom pattern. So lessons learned. Chain-based API is not a really good pattern when async calls are involved. You end up having to break the chain. Page objects and chain APIs doesn't get along really well. When you break the chain, it doesn't help with code composition, and you're still prone to the pyramid of doom. And most of the Selenium libraries are chain-based. You just get one main object. It's either a browser or the client. You just do .url, .assert, which is, I think it's good for like a really small project, but when you start to scale up your team, do page objects, code reuse, it's not really ideal. And ignore GitHub stars when you're selecting your projects, because the project with the most stars doesn't mean that's the project that you should select. We kind of learned that the hard way, because Nightwatch had like 3,000, almost 4,000 stars. 1 month later, so kind of started to miss Java, or started to miss synchronous programming. Then we took a deeper look at the official libraries, which hasn't really got much attention online. But we took a look at it anyways, because it's from the official Selenium project. It's worth to take a look. And we found out that under the hood, they give you a promise manager that kind of queues up execution. And they also provide a Mocha wrapper with this promise manager. We'll show you in a bit how it goes. But these are links you guys can actually go through and take a look. So now, this is code written with the promise manager. This is code written in Java. Hey, it looks similar now. Things are actually easier to understand using the promise manager. So how does it look with, how does Mocha look with the Selenium wrapper? So you just require the test, and in front of the Mocha test suite, you just override it, and each and every call gets added to the gets added to the promise queue, and everything just runs top down, just like Java. Everything looks sync. What I do here is you log in, make sure you click the button, make sure the element is located, and you assert on some stuff. I think it looks pretty similar to Java. It looks pretty nice, pretty straightforward. So we expanded and we experimented on this further. Comparisons. So Nightwatch is chain-based. They have their own JSON wire protocol implementation. 3,400 stars on GitHub. Webdriverlo chains promise a little bit better, but most of these have their own implementation of the JSON wire protocol, which I think is why the Selenium Node.js implementation is so fragmented. But the official libraries gives you a promise manager, which is built in. The API is based on promise. And you get to work with the native WebDriver API and the native web element and WebDriver objects. These two are really important that I want you guys to focus on, because this is going to play out how you guys integrate with other tools, like Applitools, for example, because they don't talk JSON wire protocols. They talk web elements and drivers. Oh, and the official one has 2,000 stars. So that goes back to my point. So don't trust the stars on GitHub. Page objects, everybody's most favorite topic who's doing Selenium. When designing frameworks, there is a research from a really famous doctor, the magic number 7. So the human brain can only keep track of 7 plus minus 2 things at once. When designing frameworks, you want to handle all the nuances, make the framework as simple as possible, because you already have 7 plus minus 2. Worst case, you have 5. You have to worry about the feature. You got to worry about the release. You got to worry about how to automate, how to come up with test cases. You don't want to clutter up the rest of the team with other non-important stuff that you can handle, try to handle in the framework. Another is keep tests dry, make it easy to add tests, and handle all the retries and stuff, including we had issues where the code was typing too fast. So we just implemented a common like input where we add some delays when you're typing, so it mimics an actual human typing stuff. It's not like just pasting like 100 characters where the web app doesn't really recognize when you're typing. Next is, so we want to try to implement page objects. Then we looked at object-oriented in JavaScript. So JavaScript is the most misunderstood programming language. It's not the same as Java. I know if you guys heard, but they compare JavaScript and Java as car and carpet. So nothing's actually similar in that case. Keep that in mind. There are no real classes. This is key. And the inheritance mechanism is different from Java. So JavaScript has prototype-oriented. So if you are inheriting something, you inherit the prototype object inside another object. Versus Java is kind of class-oriented, so it just extends from this guy. And this is actually this. And you have polymorphism in that way. But we need to tackle on this. And if you guys are looking to switch to Node, this is a really good book. I really recommend reading. So I think he actually knows Java also. And the way he writes it, it makes it really easy for people coming from a classical inheritance language to actually understand, which is cool. Really, really recommend it for reading before you start to design stuff. All right. So now we have JavaScript page objects. This is the parent page, which is the base page. This is the login page, which extends from the base page. But as you can see here, we're just requiring it. This is, I think, equivalent to like Java import statements. But pay attention to the constructor here, where this is where we actually implement the behavior of inheritance. So in the login page, you call the base page.call and pass in this. This is a lexical reference. We're not going to dive into this in detail. Just trust me that this works. There is a GitHub link you can try out. But this is how you call the constructor of another object in JavaScript. So what I do here is I pass in this context. I pass in the WebDriver. It actually calls this guy. So this actually gets ignored. It passes in the WebDriver, and it sets the WebDriver in the base page. So this is kind of like calling super in Java, where you call super of the parent class, and you pass in whatever you want to set in the constructor in Java to the child, to the parent class, and it gets set. The next step, we need to hook up inheritance and prototypical inheritance. So you need to call .loginPage.prototype object.create base page.prototype. So this you start to link the prototypes, and you still need to declare loginPage.prototype constructor that this is the constructor of this object here. Coming from Java, we kind of take this for granted, but in JavaScript, you need to hook this up manually. With ES6, I think it's a little bit easier, but if you want to try it out, you need to understand how prototype works in JavaScript. So moving along, in the base page, this is an example where we actually try to handle every nuances in the base page. This is an example of wait for located. So this is a recursive retry where when we find the element, we check if it's a stale element or not. If not, we retry. We retry for like 3 times, and we kind of sleep a little bit in between, if I'm not mistaken. There's a timeout, yes. So it gets set to the default timeout up there. This is a copy, so this is actually set in the base page object. And we have retries for wait for located, visible, and enabled. And then in the login page, am I going too fast here, by the way? You guys are good? Cool. So in the login page, you just call wait for displayed, wait for enabled. And as you can see, since we hooked up the inheritance already, this is actually calling the base page method. It's not calling, we don't have wait for display defined inside the login page. So this is how you go about writing page objects in JavaScript. Now, going back to Mocha Promise Manager wrapper that is given to you in the official bindings, the wrapper deals with this automatically. So each call of this is actually added to the queue, and everything just looks like Java in the rest of the page object. You don't have to deal with any callback or any promise. Everything looks clean, straightforward, and it looks just like Java. Looks really easy to understand for every other people. What am I saying? Everybody. Cool. Any questions here? This is key right here if you're implementing a page object in JavaScript. Cool. OK. It's either I'm doing a good job or I totally lost you guys. Yes?
What do the stack traces look like when you have an error let's say in the middle, and you find element by email? What does the stack trace look like?
So it actually contains everything, but then it taggles on the promise manager stack trace at the end. So you actually see the whole thing. I think that's a good question you asked. So to make sure that you get the whole stack, you need to put in error.stack in Mocha. Some people just put error, and sometimes you don't get everything. That's actually key too. Thank you for asking. That's a good question. So yeah, you need to put error.stack to get the full-on error stack. OK, now putting it together. So you have import statements, page objects, and other libraries. You have this, which is key to make your code look sync in JavaScript. This is kind of like similar to import statements in Java. And Mocha provides a before each, which is similar to add before tests in testng, if anybody here is from Java. So that's equivalent for before each test, build me a driver. And in the test, I just create a login page, enter user info, click login, and assert. It's as simple as that. So then there's no web elements here. Everything is dry. No locators, and there's no callbacks here. You just need to do a .then or a promise when you need to halt your execution to assert on something. But it's not as bad because now everything is on one level. In the next line, you can call login dot whatever, or even create a new page object if you expect yourself to be on the next page. So that's how things look when you fit everything together.
Question.
Yes?
Can you instantiate the driver in global location? Or do you have to do it in every test file?
We do it in every test file just to keep it not polluting the global namespace, because that seems to be the safer way. I don't know what your thoughts are about that.
I mean, it's good to build the driver in one way for every test, and then if you come up with a better way to build the driver in the future, you don't have to go to every test file and modify it. Putting it in the file almost makes you go to hundreds and hundreds of files over time.
Right. So there's another way to do that too, I guess. I've heard some people try to do base tests, so they do it in the base test class instead. I haven't gone around to do that yet. Keep in mind, this is just 3 months ago when we started. So it's still in its infancies.
Another question, is there a way to require all your page objects all at once so that if the test flows between many pages, does the test engineer have to think about, oh, then I need to require this page, or oh, then I need to require this page?
I prefer to keep it that way, because then you're working in your execution context. You don't get everything. I think it's your choice now if you're designing the framework. You want it to be included. And then there's an issue of autocomplete. When we were setting up WebStorm, I prefer to have it in one file, so autocomplete kind of works strictly. If you have another file, I'm not sure how that works, or I might have it set up correctly. But it seems like you have done this before, not with JavaScript. I see. Yeah, JavaScript autocomplete, it's really, you get everything, so you need to be careful. Any other questions? Cool. And feel free to ask afterwards. OK, visual validation. So we went with Applitools. I did a talk a while back, I think last year, on how we implemented Applitools in my previous company. So we have a proven track record of implementation in Java, but we want to do the same thing here as well. And we made Applitools integration a criteria when we were designing frameworks. So there are 3 ways of doing it. First is Webdriverlo's WebDriver CSS. This is a child library of Webdriverlo. Official Selenium WebDriver, which is what we're using right now, it requires the driver instance to allow you to create hook up with how you capture screenshots. And you have Protractor. We don't use Angular, so we didn't go with Protractor because it seems like there's a bunch more configuration you need to deal with. And if we don't need it, I prefer not to use it just to keep things lean. And there's a native also as well, where you actually take screenshot, manage your screenshot files, your PNG data, and you upload to the server. So don't do that. If you even have surplus teams, this is really a hassle. So WebDriver CSS. You're still stuck in the Shane API world, where WebDriver CSS gives you a client. You init it, go to a URL, call .webdriver.css. So this is when you tell your app to take a screenshot. And you need to give it a name of the locator and then you finally get assertions here. We didn't want to get stuck in the chain world, so we tried a little bit of this. Another thing that we found out was that in our tests, we used to have one test that takes one screenshot, two screenshots. Those are two separate steps. In here, these are actually two tests. So integration with Applitools from WebDriver IO's WebDriver CSS isn't that mature yet. So this is how you do with Applitools. Once you get the driver, you get the eyes object, you call open driver, and in that promise, you assign that driver back to this driver, which is then now you just assume your existing flow, what you did before with your page object, and everything just works. So this is my application context. I just open a URL, click enter user info, click login, click close, and in between, I do visual checkpoints. And we prefer to do it this way because everything looks more understandable. It's less obscure. In the test, it maintains the app context, so the automation engineer or whoever opens it knows what this app is doing when it's taking photos and comparing screenshots. A sample run. So this is Applitools. I think we use strict or we use context, but it's able to, the brightness here is not really good, but in here it's email, and in here I just type the name mech. So it is actually a result from this test right here, where I actually just override the browser before it took the screenshot, type in something bogus, and it was able to capture the screens fine. As you can see, it looks a lot better, and you get good results. Any questions on here before we move on? You guys are good? OK, cool. So HTTPS requests. So a framework is not complete until you start doing backend stuff, verifying stuff, and then doing setup via the backend. We looked at REST frameworks. The top two we looked at is Supertest and also Shikram. Links are here if you guys want to take a look. Both of them runs on Mocha and works with Mocha well. But my grip with Supertest was that you need to call done, which is like, it's kind of going back to the callback. This is a callback, so you need to call your callback to let Mocha know that you're done. And we prefer not to do that, so we cross this thing out. We looked at Shikram. Their syntax is better, where it looks a little bit sync-ish, but you need to return a promise every time. And if you omit this, it kind of breaks. So we didn't go with this as well. After this, we took a look at just a simple request library, what it does. We didn't like this as well because now you get the same pyramid of doom where you have a request. So this example is doing 3 requests. It does a post, it does a get, and gets a put. And then in order for you to do the get right after the post, you need to execute this request inside the callback of this function, and everything just goes down to the pyramid of doom again, which is not what you want to do. So the moment of epiphany. So around the same time, Node 4 came out, and I think one of our front-end devs started to collaborate, and I got introduced to generators and coroutines, which you'll see in a second. It's really cool. It makes synchronous calls act like a synchronous, looks really synchronous. And Node 4 comes with ES6 and yield statements, which pairs with generators. So yield is the keyword where you call a generator function or a call function. So this is what it looks like. There's a library called call request, so it implements call for you, but still it ties onto the request library, which everybody uses, including people who are working on Express, Backbone. Request is a really popular library. So in here, I'm just doing response, getting the result from a request. And there's no callbacks, no promise at all. But you need to put a yield statement here. And next call, I'm doing a post. There's no callback as well. You just do a yield statement here. And as you can see, I'm reusing the cookie jar. So these 2 calls are actually using the same cookie jar, mimicking a person logging into the web app. So the generator-based request became the base for our web client, which is the same principles as a page object, but for REST APIs. And the key here is yield. So it blocks the execution until it's done, and then it returns, and the next execution flows. And we still had the magic number 7 in mind, where we try to implement most of the business logic calls in the web client API in the web client class. So we have a base web client, we have a jobs client, we have other clients which does stuff like create a plan, create a job, and maps to a business logic. Same as a page object. And also, since you're working in JavaScript, there's a hidden power here. So JSON stands for JavaScript Object Notation. So if you're in JavaScript, you're talking JSON already. It's native. You're talking the same lingo. As you can see here, I'm getting an actual response in JSON back. As you can see, there's no DTOs or Jackson libraries in Java that maps JSON to a POJO. I can do .type directly in my code, and you're actually getting the data from JSON right away. There's no overhead, and everything just works with no muss or no fuss. This is actually a quote from Douglas Crawford, who is the creator of JSON. So there's a hidden power here. You can actually go with no DTOs at all and just use functional programming to parse your data. But you can just do .type, .message, and you get everything from the JSON data that you get back from a web client. So fitting it in with the whole framework. So this shows you how to do an API call at the beginning. Then you do your UI operations at the end of the test. The key to this is, again, back to the promise manager. You need to dig in really deep in the documentation to find out. But the control flows supports generators, which is this guy here, which is key here. Basically, it allows you to use a yield statement. So in here, everything is, you get a web client, that's the API stuff. I declare this so I can assign the data back. I'm getting data from the back end, get projects, and it gets assigned here. This is a util function that uses higher order functions. We're not going to go into this topic because it's going to be a lot. But you can look up higher order functions. It's really cool. Manage it can traverse your data, and you don't have to write for loops. And then I start a UI portion of the test where I have the login page. I log in. I'm at the top navigation. Then I get some data from the top nav. Then I finally assert data from the back end and the front end. So now you have full stack. You can do API UI, UI API in the full functional end-to-end test. Or you can have a bunch of API calls that does stuff to the back end, and finally have a little bit of UI verification at the bottom where you do your data, you do all your data in the back end, and then you verify it looks good in the front end. So that's what the final stack looks like. The UI framework is on Node.js. The back-end framework is also on Node.js. It uses Mocha, with the exception of the front end uses Mocha and the Selenium WebDriver wrapper. It uses Applitools. We also have an adapter that uses Co that wraps all calls to the web client. So the front-end framework can reuse everything from the back-end web client. And we use Chai as our certs. And this guy talks to the browser. Then on the back-end framework, we have co-requests. We have Mocha. There's a plugin for Mocha called Co-Mocha that allows Mocha to use co-requests. Yeah, that's how it's named, but it works. We use Chai also as well. These are common dependencies, so it's from a top level. But anyways, it's using Chai. We use JSON, which is native to JavaScript already, and we have JSchema that verifies the JSON schema coming back. So every response from a request, we check with the schema in which we do code sharing with the developers and make sure that the data is coming back correctly. And that's roughly what the stack looks like. Any questions here? Cool. Cool. OK. Introduction to deployments. So the deployment culture at Airware, so we do weekly deploys to prod every week, which is kind of like a simulated heart attack if you're on the automation team. If you deploy to prod every week. At least that's how I feel it every week. On pre-prod, we do gated deploys. And we do automatic deploys to staging and runs tests automatically every time. So we have 3 main environments. I'm going to throw it over to my coworker here, Vulcan, who is on the backend team. He leads the backend team, engineering manager. And he's going to talk about how we do deployments here at Airware.
Yeah, so I'd like to talk about our deployment dashboard that we built in-house called Vili. So why did we build Vili? The problem we're trying to solve is our architecture on the back end is a Kubernetes microservices architecture. And there's no good solution out there right now to manage and deploy many microservices in many environments with many versions. And also, there's no good way to do access control for deployments in general or to do QA gating for production deployments. And so, in case you're wondering what Vili is a Norse god. Our naming scheme in the cloud team is we name all our apps after Norse gods. Vili is the creator of the world, and Odin was taken for our monorepo, so we named it Vili. So I will go over the architecture, just a quick overview, and then I'll do a live demo to show it off. So we use Kubernetes, as I mentioned, to do scheduling of our Docker containers. We use Key.io to store our Docker containers, which has a nice API that allows us to get good information back. We would like to have multiple environments with variables, and we want to template our controllers and our apps in such a way that only our variables differ between environments. That makes possible things going wrong much less likely. And we use GitHub to manage the variables across environments, and that allows us to have a nice history going back so we can do auditing or all that. We have Vili within our firewall, but we have a second level of security by using Okta. So we limit access to Vili only to our QA and cloud teams. We also notify through Slack the cloud team and the QA team anytime something happens on Vili so that we have good visibility into our production environment. And of course, approvals also happen through Vili. QA has only the sole permission to approve a production build. And time for a live demo. Cool. Yeah, so this is the homepage for Vili. So the first thing you do is select an environment to deploy on. So if you go to pre-prod, there are two concepts here. One is an app, and the other is a job. We can ignore pods and nodes for now. They're just Kubernetes-specific things. And so a container can either run as a part of replication control in Kubernetes, which means Kubernetes is responsible for making sure X number of replicas stay up all the time. Or it can run as a job, which means in Kubernetes terms, it's a pod. So it just runs and runs to completion. And once it's done, it's done. So I will show off an app deployment today. When you go to the app's homepage, you'll see a list of apps, all the current tags that are deployed, number of replicas running, and the current approval status for each of those tags. And Tier, one of our apps right now, so this is pre-prod, by the way, and pre-prod is where we do gating, as Mech mentioned. So if you go to Tier, first of all, you'll notice on the left a column of tags. So the way we build containers is we use our git SHAs at the build time to tag all our containers as well as the branch that it was built on. So that allows us this nice view of we don't have to ever give our apps any sort of versions. They just come automatically through our git SHAs. And the branch tells us whether this was a master build or a develop build, and that helps make sure that we never deploy something on prod from develop. And Key's nice API gives us the build time and the size of the container. And we use Firebase to store the other information, such as the approval status and who approved it and the release note link and all that. So as you noticed, David Lane approved this build today at 2:52. And this is because it was approved, now it's available to be deployed on production. And before I go to the production environment view, I will also show off how we manage variables. So this view, both the template here and the variables come from our GitHub repo. We make, in the backend, GitHub API requests to get these. And you'll notice that these templates have these variables here. And these are what we differ between environments. And you will also notice that you'll get a nice view of the variables on the right side. And if you go to a different environment, such as staging, those variables will be different. All right, so let me go to prod right now. So no, not that, this one. And prod, there's a nice warning at the top saying you're on prod. Be careful. And you'll notice that the actions are slightly different. You can't approve on prod, and you can only deploy something that's been approved. So if you click deploy here, Wi-Fi permitting, it'll work. you get brought to this deployment page. You can choose a rollout strategy. These are just the ones we built in, but there's a flexible JSON description of the rollout strategy, so you can do it however you like. And there's an auto pause option, which basically means whether to pause after each step of the deployment in case you wanted to check that everything was OK before moving on. So I will go ahead and change the strategy to half and half and click deploy, and we'll watch it deploy. Actually, the screen is a little bit small, so let me just scoot down here. It's giving you a nice log of what it's doing currently. So what it's doing right now is it first set up 2 pods and made sure they were ready. And then after that stage was done, it went to the front pods and deleted 2 from there. And once those 2 were deleted, it's now setting up another one, as you see in the pending state. And once it's ready, it's going to delete the remaining pod on the left side, and the rolling deployment will be complete. And in case the app doesn't deploy, or the readiness probe fails, or the liveness probe fails, then the ready check never succeeds, and the deployment times out. And there's a way to roll back in case that happens. And that's it. So we can go back to here. I will show off the, how do I go back to the launch TV here? Oh, there, okay. Yes, so, and let me just go back to real quick to this slide. So you'll see here, this is just an example Slack notification we get. We have a link to the deployment page, so you can go directly to that deployment page and see what's going on. And you'll see some information about who created the deployment, for what tag, for which app, in which environment. And you'll also be notified when it's complete. And this will also show you errors when it times out. It's a red. When there's some sort of, when someone pauses it, it's a yellow. And
if you see anyone checking our phones, we're checking Slack to see if production is down or not. So we're checking status of our production on Slack.
Yeah. And so we are going to open source this. This is built with Go and React. It's going to be open source as soon as we're able to get around to cleaning it up and making it open source ready. And follow us on our GitHub organization if you want to be notified of it going live.
Cool. Thank you.
And
there we go. Cool. Yeah, that's all we have. We want to say some special thanks. The team here for all the support. Phil's not here today, but he worked countless nights on this Vili project. This is one of my favorite quotes from our director of engineering. This is on about coming from Java to JavaScript. So probably some unlearning going on. So you might not have to do everything in Java to expect you to do the same in Node.js. Everything is provided for you. There are a lot of microservices. A good example is underscore. So check that out. Meet up folks. Think Marcel on his advice on what he did with Nightwatch before. Marianne on the feedback with Nightwatch. The SauceLab folks, I think they're here. They came over when we were first experimenting or trying out Webdriverlo and also Nightwatch, and we got a lot of good feedback from them as well. So this whole talk is actually a summary of all the work that all these people on the slides have been helping out with, and also Applitools. It got a lot of good support from Mathan and Mocha as well. We did proof of concepts and also debugging and stuff, but they have been really great. And we open up for questions. Yeah.
So can you talk about what's happening behind the scenes when you do a deploy? Is it doing chef stuff, or is it executing anything on Jenkins or not?
No Jenkins. The app just runs by itself. All it needs to do is be able to access a Kubernetes API master. And the Kubernetes API has all this functionality around creating a pod, scaling up a replication controller, renaming replication controllers, deleting them. All that can be done through the Kubernetes API. And we also interact with KeyIO's API to make sure that that tag that someone has to deploy is valid. And we also ask Firebase whether, that if you're in production, that this tag has been verified and approved by someone.
Anything else? Cool. I think that's it. Thank you very much for coming, guys. Appreciate it.